Alright students, today we are going to continue our study of circles. We're going to find segment lengths in circles, and this is notes 10.6. Alright, to start, we are going to look at these definitions and we're going to identify the vocabulary terms. So looking here, it says when two chords intersect. So we've got this first chord here in blue, I've got another one here in green. And it says that when the two chords intersect in the interior of the circle, so here's our point of intersection, which is inside the circle, each chord is divided into two segments. So see how this chord from here to here and from here to here, that's two different segments. And then from here to here and here to here, that's two different segments. So we call these segments of a chord. On this next one, it says a segment that contains a chord of a circle. So we have this segment that's from here to here. So here's this purple segment. And inside this segment, we have this chord. So I'm going to highlight just this part of it. There's a chord of a circle. And has exactly one endpoint outside of the circle. So there's the endpoint outside of the circle, but everything else is on the circle. So we call this a secant segment. Because it is a segment, but it's touching the circle at two places. So it's a secant segment. Next, the part of a secant segment that is outside the circle. So this piece out here, right here, I have the secant segment, but we're talking about this piece right here, this segment. That's called the external segment. Okay, so now we have a couple of theorems to go through. The first one is segments of a chord theorem. If two chords intersect in the interior of the circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. Okay, so here I have these two chords that are intersecting inside the circle. And what it's telling me is that this is a segment of a chord, and this one here is a segment of the chord, and I can multiply those together. So that's A, E being multiplied by BE, and I'm just putting them in alphabetical order. It doesn't really matter if you call it EB. That's going to equal this segment here, which is CE, times this segment here, which is DE. Alright, so notice how the intersection of the chords is inside. That's important. Inside the circle. So when the intersection is inside, you just take piece times piece equals piece times piece. Alright, the next one. Segments of secant theorem. Notice how we have two secant segments. If two secant segments share the same endpoint outside a circle, then the product of the lengths of one secant segment and its external segment equals the product of the lengths of the other, need to write that, of the other secant segment and its external segment. Alright, so what are they talking about there? Okay, so here we have a circle with two secant segments, and we are trying to figure out what the lengths of them are. So here, the relationship is that the outside, which is the green one, so I'm going to call that EA. If I multiply that by the whole thing, which is EB, so outside times the whole is going to equal the outside of this one, which is EC, times the whole thing, which is ED. So outside times the whole equals outside times the whole. Notice that the intersection of these two is outside the circle. Alright, so when it's inside, it's just going to be piece times piece equals piece times piece. But when the intersection is outside, it's going to be the outside times the whole equals the outside times the whole. Alright, next. This one is similar to the one we just did because the intersection is outside. But on this one, you will see that we have the segments of secants and a tangent. Okay, so here, if a secant segment and a tangent and we're going to call this a tangent segment because usually tangents are tangent lines, but this is a segment, so tangent segment, share an endpoint, so they share this endpoint, then the, share an endpoint, and we need to say where the endpoint is because that's important. So that's going to be outside a circle, comma, then the product of the lengths of the secant segment and its external segment equals the square of the length of the tangent segment. Okay, so here it's still going to be outside times the whole equals outside times the whole. But on this one, the outside is EA and the whole thing happens to be EA. So it's the same thing, so that's why we call that EA squared. But this one is the same as the one before. So we've got EC, and then the whole thing, which is ED. So transfer that down here. So it's outside times the whole, and then outside times the whole, but this one is going to be the same thing, so it's that segment, the tangent segment, squared. And again, the intersection of the tangent and the secant is outside the circle. Alright, we have a few examples to do. Here's the first one where it's inside, so it's going to be piece times piece equals piece times piece. So here I'm going to do 6 times x. 6 times x equals 3 times 8. That's going to be 6x equals 24. Divide both sides by 6. You get x equals 4. Okay? The next one, we're going to find x as well. We're going to practice the outside times the whole thing. So here, we have the outside, which is 8, times the whole thing, which is 8 plus 8, equals the outside, which is 6, times the whole thing, which is 6 plus 2x. Now, we could add these together to get 16, so this would be 8 times 16, but over here we can't do that. So we're going to have to distribute. So that's going to be 6 times 6 is 36, and then 6 times 2, which is 12x. Okay? Now, clean it up, multiply those together. I get 128 equals 36 plus 12x. Now it's just algebra, so I'm going to subtract 36 from both sides. I get 92 equals 12x, and then I'm going to divide both sides by 12. Now, I get an ugly decimal when I do this, so I want to write down the exact answer. So make sure that you reduce it to be 23 thirds, or hit the math button on your calculator, the math enter. Okay, there's that one. Next. Okay, so here we have the outside times the whole thing. That's going to be 5 times 5 plus x equals the outside, which is 7, times the whole thing, which is 7. So that's like this one up here. Okay, so distribute. I get 25 plus 5x equaling 49. I'm going to subtract 25 from both sides. I get 5x equaling, that's going to be 24. Divide by 5 on both sides. I get x equaling 24 divided by 5. And that doesn't simplify it, so that's my answer. And they didn't tell me what to round to, so I knew I needed exact answers. Okay, next. Here's some more examples. Okay, so on this one, it's going to be the outside times the whole thing equals the outside times the whole thing. Cleaning it up and distributing, I get 16 plus 4x equaling 6 times 13. 6 times 13, I get 78, so that's going to be 16 plus 4x equals 78. Subtracting 16 from both sides, I get 4x on the left equaling 62 on the right. Now, divide both sides by 4, and x equals, and you can reduce this, but it's a terminating decimal, so we're not rounding. There is my exact answer, so that can be considered an exact answer. Next, outside times the whole. Now this one, the outside is 14. The whole thing is going to be 14 plus x plus 2. So you just you add the 14 and the 2 together, so that's going to be x plus 16 equals, outside is 16 times the whole, which is 16. Okay. Now remember, this one right here, we got this because that's going to be 14 plus x plus 2. So you just combine the 14 and the 2. Alright, so this is going to be 14 times x plus 16 equals, 16 times 16 is 256. Distribute the 14, that's going to be 14x plus 224 equals 256. I'm going to subtract 224 from both sides. I get 14x equaling 32. And then divide both sides by 14. Again, they didn't tell me any information about rounding, so I need an exact answer in lowest form. So that's going to be 16 divided by 7. All right, the next one, the intersection's on the inside, so that's the piece times the piece equals the piece times the piece. So that's going to be x times x plus 1 equaling 18 times 4. Right, distribute. That's going to be x squared plus x equaling 72. Now, this is what you need to remember from algebra. Whenever you have an x squared and an x and a number on the other side, you need to bring that number over to the left-hand side and set it equal to 0. So that's going to be x squared plus x, subtract 72 from both sides, so that's minus 72, equaling 0. And now we have to factor. Alright, so when I factor this, I want to look at this right here and say, well, what multiplies together to give me 72? 1 times 72. Okay, 2 times, that would be 36. Then you check to see if 3 goes into it. 72 divided by 3. Okay, so that's going to be 3 times 24. 72 divided by 4, so 4 times 18 is 72. 5 doesn't go into it, but 6 does. 72 divided by 6, that's 12. And then 7 doesn't go into it, but 8 does. And that's 9. Okay, and so since my next number would be 9 and I already have it, I know that this is all of the factors. So then what I do is I look at this and it says minus. So that means that I'm going to have an x here, and I'm going to have a plus and a minus sign. So I'm going to be subtracting these two factors. So if I subtract these two, I'm either going to get a positive 71 or a negative 71. If I subtract these two, I'll get a positive 34 or a negative 34. Here I get a 21. Here I would get a 14. Here I would get a 6. And here I would get a 1. So you look at the middle term, I want a 1. So this is the one that I want. I want a positive 1. So the 9 needs to be positive and the 8 needs to be negative. Okay. So your next step is to take each one, set of parentheses, the x plus 9, set it equal to 0, and your x minus 8, and set it equal to 0. Subtract 9, you get x equals negative 9, and add 8, you get x equals 8. Now if you look, x is a distance, and we can't have a negative distance, so this one doesn't work. So that's why your solution is x equals 8. Alright, next. We have outside times the whole, so x times the whole thing, which is also x, equals 9 times the whole thing. I have to add those together, 9 plus 16. Alright, so over here I get x squared equaling 9 times, that's going to be 25. Alright, so when I multiply those together, I get x squared equals 225. Take the square root of both sides, and I get x equals 15. The next one, that's going to be, the intersection is on the inside, so it's going to be piece times piece. So here I have 3x times x equaling 8 times 6. So this is going to equal 3x squared equals 6 times 8 is 48. Divide by 3 on both sides. I get x squared equaling 16. Square root. I get x equals 4. And to be honest, on these two, x is really positive and negative 15 and positive and negative 4. But remember, we can't have a negative distance. So that's why we only use the positive in this instance. Okay. The last one, I have tx is 45. So this whole thing is 45. All right, and then it says EX is 18. So this much of it down here is 18. And then I have XS, this whole thing is going to be 40. And so what I'm looking for is this piece right here, the XA. Okay, well, that's the outside times the whole equals the outside times the whole. So yellow, which is 18, times the whole thing, which is green, that's 45, will equal the outside, which is orange, or I'm sorry, the pink, which is AS, so I'm just going to put X here. Outside times the whole thing, which is the orange, so that's 40. So outside times the whole equals the outside times the whole. And then I'm going to multiply these together. When I multiply these two together, I get 810 equaling 40x. Divide both sides by 40. And I get x equals 20.25. And since that's a terminating decimal, that is an exact answer. You get an exact answer every time, you don't have to round. Okay, folks, that's it for notes 10.6.